Hello, everyone. So today we're gonna have somewhat of a shorter stream. I have some raw chicken sitting on the counter waiting for me to cook it, so I need to make sure that I finish the stream fairly efficiently. Now, it's gonna be interesting because actually there's gonna be a loud noise, but never mind. I can use the touchpad for the drawing pad for this. I'm still having problems with my trackpad, and like I said, I don't have enough USB ports at the moment to keep my mouse plugged in at the same time as the camera, so I'm trying to work around that. But we should be able to get by with the drawing tablet since everything's on my laptop screen for the stock market update. And so that's what today is. It's a stock market update, and then I'm going to talk a little bit about the game and how that's going after the stock market. But I'm going to switch the screens over here, so let's get that set up. So you can see how the scoreboard is going today. I need to grab my calculator, so bear with me. But um, as we can see, Mike has joined and has already earned a little bit of money. Megan is still topping the scoreboard, but we will see if that continues as a trend. So, like always, I need to grab a random number between 0 and 50, and we will be updating the market here. So, let me switch over to the stock market page. So, we're going to put in the prices for today, and I should actually check to make sure that this is immediately correct. So I'm going to try and go verify that because it was an interesting um, it was an interesting amount of votes this week. There were three, and they were all um, on different stocks. So yeah, there's this problem with my mouse where it just starts
Its spastic
immediately.
climb,
Oh,
although
sorry,
we
it's
might be
that's
able to
playing.
see somewhat of a trend here
Oh my
with an
gosh.
upward.
There we go. Okay, I was correct with what I thought was going to happen. So I'm going to try and get back to where I can see this stream chat. Oh my gosh, you don't understand how bad this is. To where everything that I do is being selected. Um, okay, I am very sorry about this, and we should have this back up and running in a second. I'm just going to get the random number generated. So our random number is 43, which is a terrible day. So let me go back to the live stream page, and I think we are finally back to where we were, and I'm just going to tap on my screen over here. So it seems the stream's still going, so none of that carnage was causing too much damage. So I'm gonna I have the touchpad, the drawing tablet over here. So we're gonna go through the percentages, and so red got a percentage of 33, yellow got a percentage of 33, and green got a percentage of 33. Now, this is missing 1 percentage point, but I can't necessarily round up either any of the three because that would be an unfair advantage. So we will be losing one, but I can guarantee you we will be losing a lot more because once I add this 43 market factor, you should be able to see that on the calculator. You can see that everything has tanked pretty hard. So that's a little rough. And we're going to see an interesting setup in the market if we go check out what's going on with that. So I'm going to hit new market. I'm going to zero this number out, and we will go back to the scoreboard. So you can see red is just low as it can be, even though it got a vote. And we are going to have bad days in the market. That it's been surprising that the market has been constantly going up so much. You can see that surprisingly, even Steven um, has actually stayed significantly. Oh, actually, no, never mind, never mind. Kate is actually closer to even Steven than she was last week, I believe. So Kate is taking a slight advantage from this because she has even Steven has an even spread in the market, so he will be taking the most hit from a genuinely bad day in the market. So you can see that Megan has now dropped below 300,000. I'm holding on to 200,000 here, and I think that this investment in red actually tanked pretty low because red went further down, and so Megan probably gained a little bit of a distance on me. But we are going to add these into the historic data, and then we will be moving on to the discussion. So I will point out at this point, if you want to go vote in this week's market, you can go up in the corner there. There's a little icon. It'll probably pop up right now if you're not watching this live. And if you are watching it live, you have to go up and click. I'm sorry for the extra work. So we have 45, 117, 125, 219. 45, 117, 125, 219. 45, 117, 125, 219. And I will verify that that's the correct amounts. That is the correct amounts. I think I tried to make this automated, but because I'm writing on a new line every single time, it gets a little confusing. So we're going to add the week number in there and hit update, and you can see everything kind of went down this week. Blue tanked pretty hard because blue didn't get a vote this week, which means it took the full negative 43 as it did. So you can see it was up at an all-time high. I think that I actually did benefit from my selling out at the point it did, because you can see I sold out here at this peak and then it immediately tanked, which means I could technically buy it back in and be in room for a little bit of profit, but I'm definitely waiting until blue goes further down before I switch any assets in that direction. Now, I could do something and buy a bunch more red because it's so low, and that might be something I want to do, just because I think it is actually holding the record now, because blue was at 48. 45 is the lowest it's been. You can see that on the graph. It's lower than blue has ever been. So I think that I will actually do that. I'm going to put a little bit more in red. Now, this is a big risk, but we're going to see. So if I want to get 100, I'm trying to think. If it's at 45 and I have, I'll just see how many I can get. So I have, let's just say 30,000 and divide that by 45. I could get 666.66666666. I won't be purchasing that much, and I think what I will do is I will get 250 more to leave a little bit more assets in my bank account. So we are going to purchase 250 times 45 is equal to 11,225. So I'm just going to start out by putting this at 1250, and then I will be subtracting this number from my current value. So 30,581 minus 11,250 is 19,000. I'm sorry, it's being confusing with how it's doing things. I think it's actually freezing up. I'm hoping that's not causing problems on the stream. So, yeah, it seems the whole mouse. Oh, there we go. We're back. So if I click here, I don't think Excel really likes this drawing tablet. So we're gonna delete all that and type in the number 19331, and you should see my value go back down to where it did over in the assets column. So I don't think there's any reshifting that needs to be done, so I won't be sorting this out, but this is how the stock market is standing. I'll give you one last look at the stock market in case that affects your vote, but please do go vote up in the corner. That corner, sorry, it's all inverted on the screen. Because it does matter in this game. So we have everything fluctuating based off of the votes in the stock market. So I'm going to save this out, and we are going to switch the screen. I'm going to put it on Paint just so I can give a little bit of a description, and I just realized that my backgrounds are all reset, so it's going to be red. I moved them all into a folder thinking that would be smart, and it probably was, but it would have been smart of me to reset their address location on Open Broadcaster. So what I want to talk to you guys about is neural networks. Now, I've talked a lot about this in the past, but what I'm doing with the game is I'm attempting to implement a neural network into the game that will work over time, not necessarily immediately getting an answer. It's going to be acquiring data, and that data is going to be dynamic data. So what's happening is, as the game is being played, it's acquiring more data, which means that the AI will have to relearn things. So that's an interesting concept, but at the core, I just need a neural network. Now, a lot of you might be saying, well, Jono, you do have a neural network. You use that for the past games. Now, I do have this a neural network structure that I used for, and I say structure, I don't mean that in the coding sense. It's just I have an outline for a artificial intelligence that is an evolutionary neural network at its core, and I would somewhat debate whether it would fall under the normal standards of a neural network, just because I was focusing more on a DNA structure as opposed to a synapse structure or a axon terminal structure. I didn't have any weights. What I would do is I would have this DNA structure, and that DNA structure would be randomly mutated after being mated with the current two best programs. For a random combination of the two, it would be randomly mutated, and then those mutations would be tested for their fitness, and the more fit programs would live on to the next generations. This is something that's been done a lot before, and I would question whether it fits perfectly with the definition of a neural network. Now, the neural network that I'm attempting to create for this game, at least for one kind of level of the game, is a normal textbook neural network. So what that means is that there are inputs. Between those inputs, there are weights, and between the entire input and output, there are nodes. So I'm going to draw a structure here for you to visualize that. So we're going to have something with 3 inputs, and then we're going to have some nodes here. And in the skeleton that I'm building, there's the exact same amount of nodes in each level before the input and output, but it's not really too important. It's just a little bit harder to code things when it's not a square. Then we'll just have 2 out. Actually, no. Let's just make it 1 output that's either a 1 or a 0. So what a textbook neural network does is essentially it has these connections between these nodes here, and each one of these inputs has at the beginning a connection between these nodes. I say at the beginning, it's always there, but what's happening is these connections are weighted connections. So they are going to be adjusted through each generation, and it will make it so that the inputs are more likely to spit out the correct output. Now, I'm not going to draw this next situation because there needs to be a line drawn to each one from each input, but you can get the picture here. So just continue this idea over here, and everything's going to lead to this guy over here. So what this does is, let's say that this was some set of inputs, 1, 2, 3, and we are trying to check if these numbers are consecutive or something like that. what this could do is it would take the weights and it would distribute weights across this, so that since these are consecutive numbers, this would produce a 1. And then, or if we're speaking in correct terms, usually this is some probability ranging between 0 and 1. So what essentially this does is we would have these weights. Each input is multiplied by its weight along this line towards the node, and so this node, all of the inputs that are being multiplied by the weights coming to here are summed up at the node, and we have a new value here. And essentially, when you go to the next level, you can think of that as the inputs to that level. Now, this is essentially a deep setup. Now, a deep setup would normally have more levels to it, so that there would be more layers of nodes and there's more possibilities of things happening. But what this is just 2 layers with an input and an output. And the cool thing about AI and neural networks is if you use something called steepest descent, you can optimize the program so that it constantly gets better at learning, at producing the correct answer. So if we did this and we had a well-trained neural network, it wouldn't necessarily spit out a 1, but it might spit out a 0.999, so on. And so it would say, I'm pretty confident that these are in a consecutive order. Now, these structures are used for a lot of different things, from facial recognition to simple things like, I don't know, deciding how much a house should be priced based off of features it has. But the problem, so I understand the concept of how this works, and what I'm trying to do is create a structure and outline a program so that it's a neural network that I could simply just copy and paste into another program, adjust one thing, the cost function, and it would be good to go to start working on whatever program I'm working on. And so I'm pretty sure I have the concept down on how to do that. It's all matrix multiplication. So since all of these weights have, there's this many inputs and this many outputs, what you need to do is you need to set up a matrix that will convert 3 inputs into 1, 2, 3, 4, 5, 6 outputs, which basically means that you need to take, so you have 3 inputs, and so this is going to be 1, 2, 3, and you're multiplying it by some matrix. And the way that works is you have to set up the matrix so that when you multiply, it multiplies the rows by the columns and the columns by the rows. But because it's a vector, there's only one column, so each time the vector is multiplied by each row of the matrix. So I'm sorry, I'm kind of just spitting things out here, but I'm probably going to collect my thoughts a little bit more on this and do another video explaining this in more detail. But what essentially this does is through matrix multiplication, it converts these inputs into these outputs. The matrices hold the weights that are these lines here, and then you just multiply this vector by this matrix to get this vector, and you multiply this vector by this matrix to get this answer. And in the end, you have a percentage possibility of whether this input is in a consecutive order. So how I plan to implement that into my program is I'm going to create the input that the AI will be receiving. Now, that input I decided would be somewhat built up like this, and I am running pretty late on time for what I was planning, so this will be quite short. So let's say our AI character is here. What I'm planning to do, and this is a very simplified view, is essentially have these values for the environment immediately around the AI. And so this is within the matrix, but also within the matrix, within the data that's being sent in is a compass. So what is happening is there's this circle, and I think I set it up so that there is 8 sections. So 1, 2, 3, 4, 5, 6, 7, 8. And in each one of these, there's either a 1 or a 0. So we're going to put a 1 here. And this 1 is actually telling the AI what direction the user is in, even if the AI cannot see the user. So if the user is within the AI's immediate perception, it will pop up within the matrix that it is seeing. But what's actually happening is I'm feeding in these numbers as a 1-row vector, and then there's just the 8 numbers. So 1, 2, 3, 1, 1, 2, 3, 4, and it kind of looks like that. So that's the input the AI is taking in. Then through weights and matrix multiplication, going through different levels, it will get to 4 possible answers, and those answers are to move up, down, left, or right. And so it can do multiple things at a time. So I'm going to be closing it off here because I think that I have explained what I was trying to get across. But I want to thank you guys for watching. I will be streaming on Saturday, and hopefully I will have more collected thoughts on how I want to explain this, because I do have the concepts down. I'm just kind of rushed for time here. So like I said, I will see you Saturday, and thank you for watching.